Number 1, graph the following functions. List the characteristics on the line provided. So if you're given a function, first of all, what type of function is this? Is it exponential or logarithmic? Exponential, because x is the exponent. What's the first thing you think you should do? Well, yeah, you can go ahead and determine it's a growth. How do we know it's a growth, Anna? What's not less than 1? The b value, which is the number raised to the exponent, determines whether it's a growth or decay. If your b value is greater than 1, it's a growth. If your b value is less than 1 but greater than 0, it's a decay. So she noticed right away before even graphing it, her b value is 2, and 2 is greater than 1, so it's a growth. Okay, now to figure out the rest, let's get it on the graph. Y equals, parenthesis, 2 raised to the x power, and then minus 4. So we have a picture of this exponential function, but to be able to graph it, what should we do? What's the easiest? Find some points. And how do we find points? Second table. Okay, so there's a nice point, 0, negative 3. 1, negative 2. 3, 4, or 2, 0, then 3, 4. Wait, I don't know if that's up 4, hold on. Right, 3, up 1, 2, 3, 4. And then that's enough points for the right side. Now let's go to the left and find some points over here. Negative 1, negative 3.5. Negative 2, negative 3.75. Negative 3, negative 3.875. So the further you go to the left, what do you notice the y values are approaching? Negative 4. Look, the further I move to the left, negative 3, negative 4, negative 5, all the way to negative 8 and further, it's getting closer and closer to negative 4, correct? Until it says it hits it, but it really doesn't. Okay? So you will just draw points that look like they're right on the negative 4 line. Now, what are all of those points getting closer and closer to? The asymptote. So if the asymptote is a barrier that goes through the y-axis at negative 4, how do you write the equation for that? It goes through the y-axis at negative 4. I mean, think about it. It's like y equals mx plus b. But the slope is 0, so there's no need to write the 0x. It's just y equals 0x minus 4, which can just be written y equals negative 4. Okay, now I'm going to connect those points of my curve and answer the other questions about it. What is the y-intercept? Right, they're going to write it out as a x and y value tomorrow, a point, a coordinate. What is the domain? Correct, and isn't that the domain for all exponential functions? They'll go left and right forever. And then what's the range? Correct, negative 4 is where the asymptote is, so it'll never go below that, but it'll go up forever. Now, even though negative 4 is a number, and we're kind of used to putting a bracket on a number, a bracket means that it includes it. Negative 4 is an asymptote, and it never actually touches it or crosses over it, so that's why we use parentheses. Okay, now I'm going to add something to this review because after I looked at tomorrow's test, there's something that's not covered in behavior. Okay, they'll ask about the in behavior, and they'll say as x approaches infinity, and as x approaches negative infinity, and then you have to decide what f of x approaches. Well, what in the world is f of x? Why? What does x approach positive infinity mean? When it goes to the right. So if you follow this function to the right, the y values are all going up forever. Oh, and I didn't mean to write equals. I meant to write arrows right there. What does x approach negative infinity mean then? Left, and as you go to the left, all the y values are approaching what? The asymptote at -4. Okay, any questions? On the test, this will be one of those type where it like gives you a graph and then it just gives you several boxes like domain, range, y-intercept, asymptote, and behavior. And then below it, it'll just have a bunch of answers and you have to pull the correct answer to the box. Okay? That's not so much work. Alright, B. Before we even graph B's equation, we know it's exponential because the x is the exponent and it can't be logarithmic. There's no log written there. So, what can you tell me about it before it's even graphed? It's a decay. How do we know it's a decay? The b value is 1/2. Okay, and when your b value is less than 1 greater than 0, that's a decay. Since we also know it's exponential, is there anything else we already know before we graph it? Right, the domain is what? Correct. That's what the domain will be for all exponentials. So before you even graph it, you know that. Okay, so now let's graph it. Y equals 3 parentheses, and then instead of typing 1/2, I'm just going to type 0.5 because it's faster and it's the same thing, to the x power. Okay, there's our graph. Why is it that with this graph, it's going down from left to right? Because it's a decay. How can we put it on our paper? Find some points, and how do we get to those points? Second table. Okay, obviously, I'm never going to be able to plot over here, so I need to go back closer to 0. I already see that -1/6 will be able to go on this graph. Okay, -1, +6 will be left 1, up 6. And then after that, 0, 3. And then after that, 1, 1.5. I mean, even though that's a decimal, we can graph 1 up 1.5. Okay, and then as you go to 2, you go up to 0.75. So over 2, up 0.75. And then over 3, up 0.375. So what do you notice the further you go right? It's getting closer to 0, which means we have an asymptote at 0. Okay, so I'm just going to draw in my asymptote. And how do I write the equation of that asymptote? Y equals 0. Because it cuts through the y-axis at 0. Okay, what's the y-intercept of this one? 0, 3. Now, not that you have to, because you're going to be able to graph it, but let's quickly talk about how I could have known the y-intercept before graphing either one of these. Remember, all exponential functions are in the form y equals a times b to the x. So for equation A, what is the a value? One. In there and understood 1 sitting in the a place, and then 2 is the b. So this a is your start value. So it would have started at +1. But then that -4 caused everything to shift down 4 units, which is why the y-intercept ended up at -3. So over here, the a value is 3, so it starts at 3. And then there was no shift, so that's why it's still at 3 when you do the y-intercept. Okay, range. What is the range? Correct. It goes from the asymptote and then up forever. When you're doing range, you always say down to up, how low it'll go and how high it'll go. Okay, now for end behavior. As x approaches infinity, f of x approaches what? 0. As you go to the right, you go to the asymptote. And as x approaches -infinity, f of x approaches positive infinity. As you go left, you go up. Any questions so far? Okay, can I move on? Okay, letter C. This time we're going to be graphing what type of function? A logarithmic. And the most obvious reason for that is the word log. Okay, so I'm not going to tell you tomorrow, so you need to know when you go to graph this, how do you type in this log base 5? Math. And then it's down here at the bottom, so you can keep going down until you get to it, but it's really faster, just hit up a couple of times. And then you're there. Okay, the base is 5. Inside the parentheses, you put the x minus 1. And then outside of the parentheses, plus 2. Before I even graph it, can anybody tell me what kind of shifts are going to occur? Right 1 and up 2. Okay? So, to get it on a graph, I'm going to go to the table and get some points. Why is there an error from 1 and then left forever? Well, there's nothing over there, and why is there nothing over there? There's an asymptote right here. Remember, logarithmic functions have vertical asymptotes. So I can go ahead and draw in my asymptote. And even before I graphed it, I knew there was going to be asymptote at 1 because everything shifted right 1. Okay, now let's get some points. There's a nice point at 2, 2 and 6, 3. And then on the left side, even though it doesn't show it on the calculator, it'll approach the asymptote forever. So, what is the domain? Correct. It'll never go past 1 on the left, and then it'll go right forever. What's the range? Right. Remember, with logarithms, it's always the range that's all real numbers because a vertical barrier won't keep you from going down forever and up forever. And then how do we write the equation of this asymptote? X equals 1 because it cuts through the x-axis at 1. Okay, for end behavior. As x approaches infinity, what does f of x approach? Infinity. As x approaches negative infinity, what does f of x approach? Nope. Okay, let me say it in like different words. As you go right, you go up. But as you go left, you end up going down forever, so negative infinity. All right, number 2. What is the domain and range of the exponential function? Well, if you don't remember rules, you graph it right away. Okay, so domain and range. Before you even graph this, can anybody tell me any choices that they could rule out and why? Okay, why? Right. With exponential functions, your domain is always all real numbers. So it has to be A or B, so C and D are out. And then really, you don't even have to graph it to know the range if you know the rules. You would know that this moves the whole curve up 4 units, which would make everything go up from 4 to infinity. But if you don't know the rules that well, just look at the picture. Everything goes from 4 and then up forever. So that would be B. Okay, so let's try to do this one without the rules, and then we'll graph it to confirm it. What kind of shifts are we going to see on this graph? Okay, and just for practice, to make sure you know how to type it in, how do I type in log base 5? Math. And then log base 5 of x minus 1 plus 3. Okay, write 1, move the asymptote over to 1. So wouldn't that cause your domain to be from 1 to infinity? And then the range of any logarithmic function is all real numbers, so it has to be C. Okay, right. If you know the rules and you know what everything does. Okay, number 4. Which equation models exponential growth? Which one? B is correct. And why is that the only one that's growth? It's the only B value greater than 1. On the test, I'm just going to go ahead and give you the heads up. It's a question where it'll give you like 7 equations. And it'll say, which equations model growth? Choose all that apply. So please take your time. Don't just pick the first growth you see. Look at every single equation, and every single equation that models growth, check it off, okay? Because that's just how they are now. All right, number 5. Which equation models exponential decay? C, because it's the only one with a B value that's less than 1. Okay, number 6. Many of you will be able to answer this without graphing it. If you can't, you just graph it. Y equals 3 to the x power minus 2. But before I hit graph, can anybody tell me what this negative 2 will do to it? It'll shift everything down 2, which will put the asymptote at negative 2. Can anybody tell me why that would make the y-intercept negative 1? It starts at 1, but if everything shifts down 2 units, wouldn't that put it at negative 1? Because think about it, this equation is y equals 1 times 3 to the x minus 2. So it starts at 1, but then when you move it down 2 units, it ends up at negative 1. And then you can see that on the graph. The asymptote's at negative 2, and the y-intercept's at negative 1. Okay? So D. Alright, the rest of the test, questions 8, 9, and 10 tomorrow, which they could be scrambled, so they might not end up being 8, 9, and 10, depending on how yours are scrambled, are going to be expanding and condensing. Is this currently expanded or condensed? Condensed. When they only have the word log once, that's condensed form, and sometimes that's known as a single logarithm. To expand it, we're going to have to write log base 5 how many times? Twice. We write it once for the 2. Right. And then what sign goes in between them? Plus, because in condensed form it was a product, so in expanded form you add them. Okay, so quickly try B. Okay, what'd you get? Right. Pretty much the exact same problem as A, just different numbers. Okay, C and D are already expanded form, so we need to condense them. We need to write them as a single logarithm. So that means we write the word log 1 time. They're both base 4. Since it was subtraction in expanded form, it's what in condensed? Division between what things? And is that the answer? The A is to the 3rd power. And then they might write that in parentheses. Not that it really matters because it's going to be multiple choice, so you would know. Okay, go ahead and quickly try D. Not yet, we're almost done. I'm going to add one more. Okay, what'd you get? Correct. Okay, I'm going to add one more because I just feel like it's necessary, which means it's important. Say you have log of 4x to the 5th over y squared. Before I expand that, you go ahead and try, expand it, and then I'll go over it. Yep. It's just y to the second on the bottom. What's the base when there's not one visible? 10. Yeah. Okay, can I put the answer? Alright, you should have written log 3 times. You don't have to write base 10 because it's understood. The first time for the 4, the second time for the x, and the third time for the y. X is raised to the 5th power, so on this one you bring a 5 down to the front. Y is to the 2nd power, so you bring a 2 to the front. This was 4 times x, so over here it's plus, and then they switched over to divided by y, so subtraction. And then you're done. Tomorrow's the test, so you need to use these last minutes to figure out if there's anything else you need to come up and ask me about.